All right, good morning. How's everyone doing today? So today we are going to do a little quiz review. And after we finish our quiz review, we are going to then have the opportunity to complete a quiz handout and then finally complete some other assignments that you guys maybe need to get done. So we want to try to make this one quick but understandable. So today we are going to go through our quiz to review. So a couple of things that we need to know. Our quiz is only going to have one question on it. That's it. Your quiz is one question. But you're going to have, I don't know, there's like 6 parts. So one question, 6 parts. All right, so let's just talk. So a couple things that you need to know. You guys need to know how to find the charge on an ion. And the charge is going to equal the protons minus the electrons. So if you can understand or remember that idea, that the protons and the electrons are going to determine the charge, perfect. And a neutral atom, remember, a neutral atom, when there's no charge, the protons equal the electrons. When there's a charge, the protons are not equal to the electrons. So the next thing that you need to know how to do is how ions will interact with each other. Are they going to attract, repel, or will there be no reaction? So what kind of things are going to happen here? Well, if things are going to attract, we talked about opposites attract, right? Opposites attract. So if you have a positive and a negative ion, then those are going to be attracted towards each other. Things that repel would be like 2 positives. So to repel would be like a positive and a positive, or a negative and a negative. So attracting means that these are going to come together. Repelling means that these are going to go away from each other. Okay, so the negatives don't want to be around other negatives, and the positives don't want to be around other positives. They want to be around a positive and a negative. So next, we need to know how to draw your shells. We need to know what valence electrons are, and that leads us straight in to our Lewis structures. So what I'm going to do is I'm going to work out 2 problems today. Hopefully I can get done in about 20 minutes. So first, let's just take a quick look at valence electrons. If you remember, the valence electrons are the outside electrons, and the way we can find the valence electrons, all right, the valence electrons, ladies and gentlemen, all right, oopsies. The valence electrons are going to be found with these columns right up here. So this column here had 1 valence electron. That column had 2, 3, 4, 5, 6, 7, and from neon down was 8. But then helium only has 2 valence electrons because it only has 2 electrons to begin with. So let me take you through these problems right now. So problem number 1. So we have to read the whole question. So number 1 says, there's an atom number 1 has 13 protons and 10 electrons. Atom number 2 has 9 protons and 10 electrons. And from this one question, I have everything else asked. For example, this first one, atom number 1, and it says write the symbol for atom number 1, has 13 protons and 10 electrons. So you don't have to write all this. You could do all this in your brain. I'm just showing you my thought process. You have 13 protons and 10 electrons. Now, what does that mean? Remember that the number of protons determines the atoms. That's the atomic number. And there you can see this number right here. So the atom that we're working with for this one is going to be aluminum. But the protons and the electrons are different. And so there's 13 and 10, and it says here, the charge equals the protons minus the electrons. 13 minus 10 is going to give us an overall charge of 3 plus, because there's 3 extra plus charges. So this one's going to be aluminum 3 plus. If you don't put the 3 plus, then we're going to have to mark that one wrong. Okay? The next one here is for number 2. Number 2, let's change the color. Number 2 says there's 9 protons and 10 electrons. So we have 9 protons, we have 10 electrons. And remember we talked, do we have more protons or more electrons? Well, 10 is bigger than 9, which means we have more electrons. How many more electrons do we have? Well, you can see if this one's 10 and that one's 9, we have 1 more electron. So if we use the same model, charge equals protons minus electrons, that's going to be 9 minus 10 is going to give us 1. And so there's 1 electron. So what ion are we working with? Well, element number 9 is right here. All right, so we're working with fluorine. And so we're going to write an F, and we're going to see that there's an overall, there's 1 extra electron left over. That's going to be F minus. And this is going to be the answer for the letter B. That's the symbol. So that's all you have to write. All right. Next, this one, let me just tell you, the answer is going to be attract because all the other questions are based on that. So, but will these attract or repel? Well, we have a positive and a negative. These are going to attract. So you just write attract. All right, so to review, these are our valence electrons going across the top. And then this is how you would do A, B, and C. All right, so let me take us to the next section here. All right. Let's scroll on down. So the next one. So now it says, how many of each atom is needed to neutralize both atoms? So we want to know, how many of each atom do we need to neutralize both atoms? Well, if we take a look, so let me get this going here. Okay, so let's take a quick look. All right, it says, how many of each atom is needed to neutralize both atoms? Well, we were working with aluminum 3+, and we were working with fluorine F-. So we have fluorine F-, and that's F-1. So how many of each are needed? Well, remember, the whole purpose of neutralizing is to make the charge come out to 0. So we have so just to save some time, I just got us going with the video. So how many of each are needed? So we drew our little balance beam here. And so we need to make sure that the balance is charged so that we can cancel these or neutralize these out to 0. So this side right now has a +3. This side over here has a -1. And so here's the score, +3 to -1. So the question is, what do we need more of? Does a -3 cancel out? Does a -1 cancel out a +3? No, it does not. So what do we need more of? Well, since we can't change the charges, we're going to need another F-. And, well, what does that give us now? Now that just gives us a -2. And a -2 is not going to cancel out a +3. So we're going to need another F-. Notice I can't just make it F2- to balance it out. The F's come in packages of a -1. So we have 1, 2, 3. So I'm going to cross that out. -3. Now we have a -3 and a +3. Now, in order to get full credit on this, you need to make sure that you don't leave it like this. You must write it just like this. And I'll change the color to black or something so there's no question. So it must look like this. You would need to say, you need 3. Oops. Let me erase that, please. You need to have 3 or 1. I'll start with 1. You need to have 1 aluminum. Okay, that's 1 aluminum. But if you leave it like this, I have to mark it incorrect because this is an ion. So it's 1 aluminum plus, and then you'll need 3 F-. This will be the answer to get full credit. If you write, which you guys are doing, some of you are doing, you write, oh, you need 2 more fluorines or something like that, I'm marking you wrong. you must write out 3 F minuses and 1 AF plus. Now the next one, ladies and gentlemen, says, draw the shell model for atom number 1. Well, what atom are we working with? Well, we're working with Al3+, and this is where we want to look at the shells. So we can find aluminum is right here. Here's our aluminum, right? And how many shells do we have? Well, we have each row. Remember that each row equals a shell. So each row correlates to a shell. So here we have row number 1, row number 2, row number 3, which means we have 3 shells on this aluminum. And we're not working with aluminum, we're working with aluminum 3+. So we're going to have to write A, that's probably not a good spot, I'll erase that in just a second. There's Al3+. And then we say, well, we need our 3 shells going around this aluminum. All right, we need 3 shells going around this aluminum. So the information we had from before, we had 13 protons and 10 electrons. So we know we need 10 electrons. And we know that we have 3 shells because we had shell number 1, 2, and 3. But how many electrons do we get to use? Well, it says right here, we're going to use 10 electrons. But where does each electron go? Well, let's take a look at where each electron go. Remember that each box represents an electron. So this would be row number 1, and row number 1 right here gets 2 electrons, right? Only 2. So the first shell gets 2 electrons. The second shell would get 1, 2, 3, 4, 5, 6, 7, 8. The second shell is going to get 8 electrons. The third shell would get 8 electrons. We also talked about that this section right in here, we canceled out this section and we count right past it. So if I go down to the 4th column, or the 4th row, it would be 1, 2, 3, 4, 5, 6, 7, 8. So it's pretty much always going to be 8 as far as we're concerned with these valence electrons. So I don't know what color that was. We'll just call it right about there somewhere, huh? Where are we? Whatever. Okay, so how many shells are we? How many electrons we use? Well, we're going to use 2 electrons are going to be on the first shell. There's 1, 2, and then we have 8 electrons on the second shell. 1, 2, 3, 4, 5, 6, 7, 8. And at that point, we've used up all 10 because we need 10 electrons to be used, right? 10 electrons to be used, and we've used up 10 electrons. So at this juncture, you can see that we're all set. Because yes, aluminum has 13 electrons, but it's lost its 3, so it only has 10. Now, what we have, we can see that we have the first shell has 2 electrons. And the first shell will always have 2 electrons. Some of you are pouring more in there. Sometimes some of you are putting in 6 electrons, but the first shell only holds 2, and the second shell can hold up to 8 electrons. And if we needed to, the third shell could also hold 8 electrons. Now, how many shells do we have? Well, it says we have 2 shells, but remember, 3 shells, but remember there's no electrons in this shell. So we're going to lose this shell right here, right? So our response would change to not three shells. It would change to 2 shells. So this one only has 2 shells when we draw our shell diagram, all right? First shell has 2, second shell has 8. So let's draw the shell for atom number 2. Atom number 2, ladies and gentlemen, was fluorine. So it's F minus. And we were told that F minus had 9 protons and 10 electrons. And that was this atom right here, 9 protons and 10 electrons. So this atom here, fluorine or fluoride, but this fluorine atom right here, which has 9 protons. This one has 10 electrons. So we're going to do something very similar. So we want to draw this out. Now, how many shells will fluorine have? Well, there's row number 1, and there's row number 2. So fluorine has 2 rows, so it's going to have 2 shells. So I'm going to put an F minus right in the middle, and then I'm going to draw 2 shells. There's shell number 1, and there's shell number 2. So how many electrons can we put on the first shell? Remember, the first shell can hold how many electrons? It can hold 2 electrons. 1, 2. All right, there's my 2 electrons. So my first shell can hold 2 electrons, right? There are my 2 electrons. Shell number 2 can hold 1, 2, 3, 4, 5, 6, 7, 8. And we have 10 electrons because it tells us we have 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to put those going around the second shell. Why the second shell? Well, because these electrons are on the second shell. And that's the thing that's beautiful about chemistry is there's no questions. It's on the second shell, it's on the second shell. And so this right here would be the shell model for fluorine, and this would be the shell model for aluminum. Okay, so the last part that you're going to have to do, this is G and H, is you're going to have to draw the Lewis structure. Now, the Lewis structure of an atom, this will be atom number 1, which was aluminum, deals entirely with the number of valence electrons. The valence electrons are the outside electrons. So, for example, the last one that we're going to have to do says draw the Lewis structure, and it entirely deals with the valence electrons. Again, these would be the valence electrons. So lithium would have 1 valence electrons, potassium would have 1, beryllium, magnesium, however many. But the valence electrons also, what these are the total number that are in the outer shell. So to draw our Lewis structure for our aluminum, is we put our aluminum 3 plus right here. We put our aluminum 3 plus in the middle, right here. And then we're going to draw electrons going around the outside. Now remember, we always start and go clockwise. So that's going to be 1. Let me make that a little bit bigger for you. There's 1, 2, 3, 4, 5, 6, 7, 8. Why? Because we have 8 electrons in the outer shell, and that's what the valence is. Again, the valence electrons are the outer electrons in the outerest shell. And then we'll do the same thing for fluorine. So here's fluorine with a -1 charge. And we're going to go to our electron colors. There's 8 on the outside. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. Each one of these, that's our Lewis structure. All right, now pay attention to how we do the Lewis structure. Some of you on your assignments were putting the protons and neutrons. You don't need to do that. You just write aluminum 3 plus or F minus and draw the number of electrons that are on the outside. Now remember, if there's a question, which there probably will be, that says something like carbon. Well, carbon would be a neutral atom, so how many valence electrons would carbon have? There's carbon. Carbon is in the 4th column, so it has 4. 1, 2, 3, 4. What if it was fluorine? Well, if it's just plain old fluorine, there'd be 7. 1, 2, 3, 4, 5, 6, 7. But why are there 8? Well, because there's an extra electron, and that's given to you in the problem. So let's do our last example. So if you could do that last example, then you're in really good shape for understanding and doing great on the quiz. I'm going to do another example for you right now. This one, I'm going to go somewhat quickly on this one to speed you guys up. You can slow the video down if you need to. So this question, which will be exactly like what you have on the test or on your quiz. Again, you only have this one question with the 6, 7 parts. So atom number 1 has 4 protons, okay? 4 protons and 2 electrons. All right, now, what does that mean? Write the ion symbol for atom number 1. Well, protons tell us the atom, so we're going to be working with beryllium. Okay, so there's beryllium. And beryllium, it looks like there's 4 protons and 2 electrons. And remember, it's the protons minus the electrons. So the charge equals the protons minus the electrons. So the protons minus electrons equals 2. This is a positive number, so it's going to be 2 extra protons or an extra 2 plus charge. So we're working with beryllium. So what's the symbol going to be? So we have beryllium right here. Beryllium with a 2 plus charge. And boom, you have the answer. Well done. All right, so let's go to the next one, right? The atom for number 2. This one, we have 15 protons. Ooh, scary. And 18 electrons. Let's find it. Here's 15. All right, so it looks like we're working with this phosphorus thing. So what do we have? We have, what does it say? It says we have 15 protons, and we have 18 electrons. And again, the charge equals the protons minus the electrons. So 15 minus 18 equals 3. Since the electron number is bigger, there's more electrons. That means there's going to be 3 extra electrons, which means the charge on this one is going to be 3 minus. So this phosphorus here is going to have a 3 minus charge. And that is everything that's being asked of these first 2 questions. Now the next one says, are these going to attract or repel? Well, that's a positive and that's a negative. So these are going to attract, like I told you before, it's always going to be attract because I'm giving you a quiz and I need to continue the questions. Now, the next one says, how many of each atom is needed to neutralize? So remember, we need to take this and neutralize it out to 0. So we need this to come out to 0. So this red has to cancel out the blue. That's going to turn everything to purple. So how many of each are we going to need to get to 0? Well, we have a 2 plus charge here and a 3 minus charge here, right? And so what are we going to do? We're going to take another Be 2 plus. Because right now the score is 2 to 3, and now the score is what? Now I can only add it in 2 pluses. Now we have a plus 4 to a minus 3. That is not going to balance us out to 0. So let's add another phosphide or another phosphorus ion. Okay, so now what do we have? Now we're at minus 6, still not balanced. So let's add another beryllium. That's a plus 2 charge. And sure enough, right now, what do we have? We have a plus 6 here. We have a minus 6 here. And these are going to cancel each other out perfectly to 0. So that's a plus 6 charge between those 3 berylliums. And that's a minus 6 between those 2 phosphorus. So what would our answer be? Our answer would be, down here, you would say I need 3 Be 2 plus. If you forget to put the 2 plus, kids, I have to mark you wrong. Sorry. You have to put that because you don't need 3 Be's. You need 3 Be with a 2 plus charge. And then you would need 2 P 3 minuses. And that's it. You have the first 4 questions. This just took me, what did it take me? That just took me about 2 minutes, 3 minutes, and I'm explaining it. So this, I always multiply by 3. So this should take you about 6 to 7 minutes. The C shouldn't take you any time at all. The D might take you some time, and the A and B will take you some time. All right? So we're going to move on from here. So let's clear the screen. All right? And let's move to the next section. All right? So this one says, draw the shell for atom number 1. Okay, so what I've done here is I've just brought this information down for us. So this one will be the beryllium 2 plus. This will be the phosphorus 3 minus. So let's draw the shell model. And remember, the shell models are going to look like this. Okay, we're going to be drawing all those little circles. So the first thing we have to do is say, well, how many shells will beryllium have? Well, it looks like right here, beryllium's going to have shell 1. Looks like it's on the second shell. So beryllium 2 plus looks like it's going to have 2 shells. All right, so you'd say it's got shell number 1, and it's got shell number 2. And you say, well, how many electrons do we have to put in this shell? Well, you have to look back to what you're given because you're working with Be 2 plus, and you have 2 electrons. So where are we going to put these electrons? Well, let's just start counting. So we have 2 electrons, 1 and 2. And sure enough, we're done right there because we're on the first row. But Mr. P, it says 2 electrons. I mean, 2 shells, but we don't need 2 shells. So it looks like we just have those 2 electrons. So we don't have 2 shells. What do we actually have? Looks like we have Oops, I didn't mean to erase that one. I'm getting a little too close there. All right, looks like we have just the one. Oh, man, looks like we have just the one shell, ladies and gentlemen. Okay, looks like we have just the one shell. And there it is. That's the shell model for beryllium. Now let's do the same thing for phosphorus. We have phosphorus is on, let's see, that's shell 1, shell 2. So phosphorus is on shell number 3. All right, so this phosphorus 3 minus, you're going to need 3 shells. There's 1. There's 2. And there's 3. Now, drawing a little sloppy. If I wanted to, I could have also used the insert, and I could have drawn my 3 shells that way, which I might do just to show you again. So, how many electrons do I have? Well, I have 18 electrons. Let me erase these last 2 electrons so you don't get confused with those. I have 18 electrons, which means I'm going to have to fill those electrons in, right? So I have 18, and those 18 electrons, where are they going to go? It's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So those are my 18 electrons. So I get 2 electrons in the first shell. That's the maximum number. There are my 2. And then I get 8 electrons in the next shell. 1, 2, 3, 4, 5, 6, 7, 8. And then I get 8 electrons in my third shell. And I'm just going to put them in like this because I know it's 8. 2, 4, 6, 8. Boom, we're done. This would be the shell model for phosphorus. And now this is going to take us to the next question, which I'm going to leave this up, but G and H would say, draw the Lewis dot structure. So I'm just going to draw the Lewis dot structure for you right now. So the Lewis dot structure, which would be the next question. So remember, we care about only the valence electrons, only the electrons on the outside, and beryllium has 2. So it would be like this. It would be beryllium 2 plus. And then you also remember, we always go clockwise. All right. And then it would be 1, 2. So that's the Lewis dot structure for beryllium. All right. And then for no, this isn't fluorine. For phosphorus, how many valence electrons or how many electrons are on the outside shell? Valence electrons means the same thing. So how many valence electrons? We have 8. So we need to put 8 electrons going around this whole thing. I know it's going to be this perfect setup, right? Because I know there's 8. And this would be the Lewis structure. So this one here would be the Lewis structure, shell model, shell model. So if you can answer these 2 questions with confidence, jeepers criminy. Whew, sorry, I think my dog is coming in. Hold on, that scared me. So that was my dog, this little monster. Scared me to death, didn't you? Didn't you scare me to death? All right, so if you can answer these last 2 questions, then you're going to ace the quiz. If there's areas where you're struggling going, man, I can't remember what the shell model is, ask me for some help or just review this video and go back and go, okay, well, Pepe just showed us 2 examples plus the other videos he's done. So take a look. All right, if you do have any questions, I'm sitting right here. And that's it. Good luck. Do your quiz review. Complete all the other handouts maybe that you haven't completed yet. And then we'll take our quiz next class. Okay, have a very, very good day. I'm sitting right here for you.